This lesson is on some of the characteristics of polygons. We'll start here with polygon. What's a polygon? Well, a polygon is a closed figure with straight sides. A closed figure with straight sides. Okay. For this class, you will need to know these terms. There are others, but you'll need to make sure that you know these particular names of polygons. The other ones you won't necessarily need to know. They're fine, and there are names for them, but you don't have to know them for this class. We have the specific names. They tend to come from Latin or Greek roots. And then we have engon, which is the general term that we use. For example, if you had one that you don't know and you were trying to find out how many sides the polygon had, you would in the interim call it an engon till you figure out what the number should be. If you're using a polygon that has more sides than this, then you could use it, say if we had a 17-sided closed figure with straight sides, you could call it a 17gon. Yes, there is a name for it, but you don't have to learn it for this class. It's okay to say 17gon. That'll work just fine. And notice here that there are two acceptable names in English for a 7-sided closed figure with straight sides. That's a septagon and a heptagon. Septagon is from the Latin root meaning 7. Heptagon or hepta is from the Greek root meaning 7. Don't we have September? That's a month. Wait, September is the 9th month. Why does it say 7th month? Well, as it so happens, it used to be the 7th month a long time ago, but Julius Caesar wanted a month named after him, and so we have July named after him, and he put it where he wanted, which was before the 7th one. And then Augustus Caesar wanted a month named after him too, and if you're king, you get to do that. And so he named one off after himself, August. Augustus Caesar, that comes to us as August. So what that means is our months are off by 2. September, at one point, should have been the 7th month, but now it's the 9th. October is the 10th instead of the 8th. December is the 12th instead of the 10th. So, thank you, Julius Caesar and Augustus Caesar. Polygons. Let's look at my polygon here. Okay, this is a closed figure with straight sides, so it is a polygon. What if I do, well, let's see, I do this. I kind of cave it in. What if I have a paperclip that's running around looking for a place out of the storm? Oh my goodness, I'm going to come in here into this cave and I won't get rained on. So the paperclip gets to stay dry because there's a cave in the polygon. We call the polygon, wait for it, concave. Okay? What if there's no caved in place? The paperclip's looking around, going around, running around. No place caved in, no cave to hide in to get away from the storm. Oh, poor paperclip, gonna get wet. This is not concave polygon, it is a convex polygon. Now, most mathematicians, as I've looked at it, some do one way, some do the other. Some define what concave means, and then says convex is not concave. And then some define what convex means, and say concave is not convex. Did I say that right? You got the idea. So your book, what I just did is I defined concave as having an interior point, one that pushes in, and said that everything that's not concave, that there is no cave, is convex. I happen to like this one because the word concave happens to have the word cave in it, which really doesn't go with anything, but it helps me remember it. Your book, and some other mathematicians, define it the other way. They define what is convex. This is the definition of convex, and then say whatever is not convex is concave. Go ahead and write this stuff down, but that's a kind of wordy thing. No line that contains a side of the polygon contains a point on the interior. What does that mean? Okay, here's what it means. So if you have, here is a concave one. This is convex. Here's a line that contains the side, and the line is on the side or outside. No part of the green line goes inside the yellow. As opposed to convex, if I extend this purple side through, then part of the red line, the extension of the purple, is inside of the polygon, therefore it is concave. So either type of definition works just fine. I like the cave because of the coincidence of it being part of the word concave. So it makes it easier for me to remember. Whatever is easier for you is just fine. We have a few more definitions to deal with for today's lesson, and that is, for polygons, we use the term equilateral when all of the sides are congruent. All the sides of the polygon have the same length. We call it equiangular when all of the angles in the polygon, the interior of the polygon, are the same measure. If it's both, we call it regular. Congruent sides and congruent angles. So the word regular has a very specific meaning in geometry. Let's look at a few of them. Okay. Is that a polygon? Yeah, that's a polygon. It has flat sides, it's straight sides, and it's closed. It is concave because it makes a cave that you can hide in. This is not a polygon because it has a curved side. It's a piece of pie. Maybe cherry. I'd like some cherry pie, especially if I can have whipped cream on it. Okay. It's actually two polygons that share a common vertex, two triangles. This is three polygons, the whole big one, which is concave with a K, the one to the left, which is concave, and the one to the right, which is convex. This is not a polygon because it's not closed. Remember some of our uses of markings? This is a regular polygon because all of the sides are affirmatively marked as being the same length by the hash mark. Recall that when the same number of hash marks are on two different segments, they are the same length. All of these have the same hash mark. They're all the arc mark on it, which says that they're the same measure, which means that this is regular. This one is also regular. It's not marked as regular with the hash marks are marked. This is neither equiangular nor equilateral. It's a triangle. Okay? And here ended the lesson.